All right, this is lesson number 38, factoring greatest common factors. And you should have a set of guided notes with you. If not, you can find them on Skyward, and I'll let you find that on your own. And I also passed them out to you in class. So here we go, lesson number 38. The first thing we're going to do is basically introduce a few key ideas. So I'll give you that first. Then I'm going to show you how to factor. There are basically 4 steps. Eventually, you're not going to have to do all 4 steps. You'll get pretty quick at it, but to first learn it, you kind of have to see all the steps. And then on the back side, we'll do some practice. So I've got, I think, 5, and then there's a 6th one that we're going to practice, and we'll fill them all out as we go along. You are expected to complete the whole guided notes with me. So when you turn it in tomorrow morning, or tomorrow, whenever that may be, during class or at the beginning of class, it all needs to be filled out. Everything just as I do it on the video. So make sure and complete that as we go along. So here we go. Here's the first one. It says, introduction. For many lessons, you have learned how to successfully distribute, and we've done that. You can distribute. For example, distribute the following algebraic expressions. So here's the first one. I'm going to go ahead and zoom in just a little bit. We've done this so many times, you should be able to do this fairly quickly without making any mistakes. So we're going to multiply the 6 times the x, we get 6x, and then 6 times the 5, and we get 30. All right, now, tonight's goal is this. We just went this way, and we call that distributing. And it'd be nice if my pencil had an eraser. We call that distributing. There we go. Today, we're going to go backwards, and we call that factoring. That's the title of this lesson, factoring. So everything we do today, everything I do in this lesson, we've already done, but we've done it in reverse. All right, so let's fill out these blanks to make sure we've got it right. It says in this lesson, we will be distributing in reverse. If you can think of distributing as going forward, so this is going forward, this factoring is going to be going backwards. Then you can think of factoring as going backwards. That's a little better. Distributing, which is moving forward, and factoring, moving backwards, are just the reverse of each other. All right. So how do you factor? How do you go in reverse? All right, the first thing we have to do is find the greatest common factor, which is the GCF. I know you all have done that before, but just in case you haven't, I'm going to go ahead and do it with you real quick. So we have 2 terms in this particular example. We have 6 and we have x. So I'm going to go ahead and write both of them down. We have 6x and we have 30. Those are my 2 terms. 6 is the same thing as 2 times 3, and then I'll carry along the x. 30, now if you need to break it down over here using a factor tree, go ahead and do that. So that's 2 times 15 and 3 times 5. So 30 is 2 times 3 times 5. All right, so the greatest common factor is the numbers or variables that they have in common. So in this case, they have a 3 in common, and they have a 2 in common. So the GCF in this case is 2 times 3, or 6. So the greatest common factor between these 2 terms is between 6x and 30 is 6. All right, the next thing we're going to do, next step, it says write the GCF, which is in this case 6. We're going to write it outside a set of parentheses. So we'll write down a set of parentheses. Actually, the first step maybe is rewrite the original problem. Let me do that first. So we've got 6x plus 30. I found the GCF to be 6. I write down parentheses, and on the outside of that, I write the GCF. All right, the next question. So what belongs in the parentheses? So I wrote this parenthesis here, and I need to figure out what goes in there. So what belongs in the parenthesis? Whatever remains after the GCF is removed from each term, that's what belongs in the parenthesis. So if I go back up to here, whatever is not removed, well, if I put the 6 on the outside, if I remove the GCF from both of those, I'm left with an x in the first part and a 5 in the second part. So it's going to be x plus 5. So my answer on this one, if this is my original, is 6 times the quantity, x plus 5. And I just factored. Now the next part is kind of interesting. It says you can check your answer by distributing. If after distributing your answer, you end up with the original problem, then you factor the problem correctly. So let's do that. Let's go ahead and take our answer and distribute. So 6 times x is 6x. 6 times 5 is 30. And notice, this and this are the same thing. If I finish after I distribute, if I finish with my original answer, then I was correct, and there's my answer. Okay, if you flip this over, we've got 6 problems we're just going to work through. So here we go. All right, for the first couple, I'm going to show you how to find the GCF the long way, and then I think most of you can probably find it the shorter way, and then you can start seeing it as we go along. So here's the first one. So 3x squared is the same thing as 3 times x times x. Remember, x squared is x times x. 12x. Now, if you do the factor tree for 12, I'll do factor tree for 12 right here. So we'll go 12. That's 2 times 6, and then 2 times 3. So 12 is going to be 2 times 2 times 3, and then the x. The x is important, not right now, but later on it'll be real important. And then 15 is just simply 3 times 5. So what's the greatest common factor? Well, they all have a 3 in common, and these two have an x, but they don't have an x down. This guy doesn't have an x, so they don't have an x in common. That's it. So my greatest common factor is 3. So remember what I do is I put the greatest common factor on the outside of a parenthesis, and then whatever's left is what goes inside the parentheses. So I got x times x, and that's x squared. I have 2 times 2 times x, that's 4x. And then I have 5. And I got to remember to bring down the minus sign, so minus 5. I can check it. 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times negative 5 is negative 15. And that gives me the original, so I know I've got it right. You don't have to physically check it. I would recommend that you mentally check it, but you don't have to physically check it on the homework. All right, here's a couple more. So we've got 15. Let's see, 15 is really going to be, that's 15y squared. So that'll be 3 times 5 times y times y. 10y is going to be 2 times 5 times y. Let's see, now 50, and that one I need to break down, so I'll break it down up here. So 50 is going to be 2 times 25, and then 5 times 5. So that'll be 2 times 5 times 5. All right, now I'm looking for the greatest common factor. This is what they have in common, and it looks like they have a 5 in common. They don't have anything, all three don't have anything else in common. I mean, these two have a y in common, but this guy doesn't have a y. And these two have a 2 in common, but this guy doesn't have a 2. The only thing they have, all three of them have in common, is the 5. So, remember, I write the GCF outside the parenthesis. Whatever's left is what I put back in. So it's 3y squared minus, from up here, 2y, and then minus 10. I can check it. 5 times 3 is 15, y squared, minus 10y, minus 50. And if that's what I originally started with, then this is my answer. Okay, I'm going to try to do it without showing all the little steps, so like this stuff over here. So here's the next one. I got 12, 15, and 9. I need to know, what number goes evenly into all three of those. That's my greatest common factor. And if you got good multiplication tables, you'll probably recognize that 3 goes into all of those. So the next question you have to ask, well, what belongs here? What's left? Well, if I take 12 and divide by 3, that's 4. And there's the a squared. Remember, I can always work backwards. So I should be able to go 3 times 4 and get 12. For example, if I put 2 right here, 2 is not correct because 3 times 2 doesn't give me 12. I always have to be able to go backwards, and so it's going to be 4 there. All right, the next one. What do I have to multiply by 3 to get 15? That'll be negative 5a. 3 times 5 is 15. 3 times negative 3 is 9. And I can check it. 12a squared, negative 15a, and negative 9. And that's what I originally, and there it is. Okay, the next one, number 4. I'm looking for the greatest common factor. Well, 4 doesn't go into 30, but I know 2 goes into both 4 and 30. So 2 is going to be my greatest common factor. Let's see. Well, how many times does 2 go into 4? 2 goes into 4 twice. 2 times 2 is 4. I just quickly mentally check it real quick. And then 2 times what gives me 30? That's 15. So 2 times negative 15 is 30. So there's 4c minus 30, and that's what I originally had. And there's my answer. Here's another one. 6, 15. What do they all have in common? They all have a 3 in common. So there's my greatest common factor. 3 times what gives me 6? It's 2. Double check. 3 times 2 is 6. What times 3 gives me 15? And that's going to be negative 5. So 3 times 5 is 15. Make sure that you carry down these x's as well. I think that's one thing that a lot of students forget to bring down. And then the last one, 3 times what? What do you do here? What's left? Well, in this case, it's going to be a 1. I have to put a 1 there. So 3 times 1 is 3. If I left it like this, and I didn't leave this guy, when I factor back, when I distribute back through, I won't get my original answer. It'll be 6x squared minus 15x, but I won't have that 3 there. So this is incorrect. I have to put the 1 here. So that gives me 6x squared minus 15x, and then that minus 3 shows up. So there's my answer. Okay, so we got a couple blanks to fill in, so let's do those next. All right, it says beware. If by removing the GCF from a term removes the entire number, just like this 3 did right here, replace the term with a 1, not with a 0. A lot of people put 0, and that's incorrect. If the term is entirely removed and not replaced with a 1, when you check your answer by distributing, you will not return to the original problem. Remember, you always have to be able to return to the original problem. Okay, the last one is right here. So we're looking for a number that goes evenly into all 3 of those. And if I think about that a little bit, I'm not seeing anything that goes into those, because if I write on the side 3x squared, if I write the greatest common factor out kind of the long way, there's that. 2x is just plain 2 times x, and then 5 is just plain 5. Do you see that all 3 do not have anything in common? I mean, these 2 have an x, but not the third one. None of them have anything in common. And when that occurs, we give this a special name. We call it prime. So if it can't be factored, if we can't find a GCF, we call it prime. All right, and the last one, last bit, if an algebraic expression cannot be factored, the expression is considered prime. All right, there it is. When you get in class tomorrow, I'll collect this from you, and then we will do the problems in class. We'll leave the whole hour to do the whole thing. That's the advantage of doing this in evenings. We're done.